All right. All right. If you're a civil engineer and you're watching this, come closer. This video is for you. We are going to be going through a deep training on road design using Civil 3D. You agree with me that Civil 3D is one of the most recommended and the most widely used road design software or infrastructural design software. So I'll be taking you through that process on this particular course on YouTube for free, right? But then we have a very great course that is available, and we are also going to be having our training, official training course, which is going to be coming on the 3rd of November. The link for registration will be available very soon, so you can register with us. Secure your seats today and thank me later. All right, we'll be using Google Earth to generate our survey data, so let's jump right into it. But then, my name is Abel Gray Kantoma. I'm from Greatest Design Consults. This is my WhatsApp contact. You can reach me on this number or call me on any of these numbers, okay? All right, so let's look at Google Earth. Google Earth. So you need to get Google Earth. It's a free software that you can take advantage of. Just download it, go to your browser and download Google Earth. So we'll be using Google Earth to generate our survey data. So let's look for, I'm just going to stadium. So let me look for a location in Kaduna. Mind you, your system has to be connected to internet in order for you to use Google Earth, okay? Perfect. So this is Amadou Bello Stadium. So I would like us to, I think, design this road, right? So one of the very important thing that you must do on road design is to do a good reconnaissance survey. This is an existing road, so we are just going to be designing this particular road, although because this is a training and this is going to be our first class, so it's important that we make it a bit simple. This road has a median separator here, as you can see. This is a 2-lane carriageway, and then we have these here, we have these here. Perfect. 2-lane carriageway here, another 2 here. So that is that. So quickly, in order for us not to waste much of our time, before we generate our survey data, I would just like to demonstrate something very important that I feel we need to establish based on reconnaissance survey, like I said earlier. So part of what we need to do is to let me use my part. I'm just going to use a part to, although I'm not going to really use this, so let me just call this T1. I'm just going to draw some parts here. So Google Earth is a very simple software that you should use. It's not very difficult to learn. So let's just pick this point and let's see what we have, right? So if you can make it as straight as possible, is better. It can be straight, is better. Whoa, I'm still very far from there. Right, it's all good. So this is usually very good for presentation drawing. If you want to do a presentation drawing, you can generate your survey data for presentation, but it's not very advisable to use the data you get from this for a real life project. You only do that for. So let us pick our point. So one very key important thing you need to know, although we've not gotten to that point, I will explain as we progress. Let's just pick our points. Okay, I would like to stop here and then view the cross section of this. So let me see how this cross section is going to look like. I will right click on it and I will come to show elevation profile, right? So this will show me the elevation of this road from the beginning. You can see as I hover my mouse along the path, you can see there is an arrow at the top there showing me how many kilometers this road is entirely. So this is 1.91 kilometer, so which is almost about 2 kilometers, right? Now if that is correct, one very important thing we need to also know is the maximum and then the minimum slope. You can see here we have 7.0%, then we have minus 3.7%. so this will tell you your highest point, and then this will tell you your lowest point. You can see this is at this point here we have about 597. If you come down here you have 580, which is about 7 meters difference here. Here we have 590. This is about 6 meters difference. So at this point this should be our lowest point. So but basically what we are saying here is we have you can see it tells us the distance of 1.91 kilometer, which is the entire length of this particular road. We have our average slope of 1.8%, and then we have minus 1.1%. This is a very important information. Now you agree with me that we have classification of topography. So now this is the topography of this particular road, right? Now based on the class at which this particular road falls in, it falls in the. So if you look at this falls within the class of a flat terrain, and I will explain why. So if you look at this, based on what we have here, we have our percentage of slope. You can see we just have that grade of 7% and then minus 3.7%. So this actually falls within the flat terrain topography based on classification of topography. Now let me explain. For the flat terrain is usually from 0 to 10%. For rolling terrain is usually from 10 to 25%. Then for mountainous terrain is usually from 25 to 60%, right? So this is basically telling us that this terrain is flat. Now because of that, it's also very important that you know, let's come to our Federal Ministry of Works manual, highway manual. So if we go to our Federal Ministry of Works Highway Manual, where do I have this, please? So if you look at this now, we have for flat terrain, you can see for the design speed is recommended that it should be around 80 to 100 kilometer per hour. Now there are so many other things that are being considered. We have different classes of we have different class of road. We have class A, class B, class C, class D. Now always recommend that you get this highway manual for Federal Ministry of Works highway manual. It's very, very important that you have it as a civil engineer who is very, very much interested in road, right? So this class, you can see this is class D, which is for minor road. We have the minimum design speed of 40. We have the class A, class C. This is basically class C. So you get to know and get to understand what particular class does your road falls in. But for those that are very, very conversant or familiar with this road, this is a very, very popular road in Kaduna. We call it Constitution Road. So this road, this is the roundabout from the stadium, which is called the stadium roundabout, and then this is the roundabout around the police college. We have our police college around here. This one takes you to Kabala. This road here takes you to Gamji in Kaduna, right? So that is that. So if that is correct, now we have been able to know what class of topography this particular road is going to fall on. So we know that based on the percentage we have here is just within the flat terrain. So definitely this road is a flat terrain, right? And then we can adopt, let's say, 80 kilometer per hour, because this is not a major federal highway, right? So on this road, 80 kilometer per hour is actually very, very good. I will suggest. Now if you look at this, I believe this is a stream. I know this location, but I can't remember the name of this particular point. There is one filling station around this particular place. So there is a water that crosses, you can see, I think is a stream that goes across this. So we have a very low level here. Now one of the most common questions I get is, how do you know that you should have a bridge or you should have a culvert at a particular location? Now this is another way. Now it is always very, very important that as an engineer you visit the site to see for yourself. Have a physical inspection. Go there for physical inspection to see how the nature of that particular terrain is, in order for you, that will help you to know how to come about your design. It's very, very important. And in reconnaissance, this is also a very, very important feature that you must take note of. You must take note of existing drainage, if there be any existing drainage there, before you propose that road, because that will also help you to know how to connect whatever drainage you are proposing to the existing drainage. That is also very important. If there be any road, maybe like an existing road that is close to this your site, let's say for example this road has not been constructed but this one is constructed, this one is already existing, for example. Now it's important that you also take some points along this, because in order for you to know how to link the edge of asphalt of this, we call edge of asphalt, from this road, how do you link it with this? They are supposed to fall at the same level. That is also very, very important information. You take note of if there be any fence. You take points along where you have trees. You take those points. These are very, very key important features that you must take note of. If there be existing hydraulic structures like culvert, existing bridge, these are also very key important features that you must actually take note of. So I have spoken extensively about this. So in the next video, I'm going to show you how to insert, generate your points from the Google airplane. Just to add more to the point, it's very important that you take note of the low point. These low points, they are very, very important. These low points really tells you that there will be need for a cross covert, box covert, right? So these are very, very important to really take note of. And even from here, you can see obviously that our lowest point happened to be here. You can see there is a water that crosses along this part. So this tells you that we'll have to have a culvert along here, which is our lowest point, right? Now, if that is correct, another very, very important thing you need to do, let's say we close this. In your reconnaissance survey, you should take note of the right of way as well, right? So you can do a little measure. Let's say we measure from here to here. You can see this is about 17.3 meters. You know, there is a standard right of way for highway, most especially. We have the highway manual, right? So the highway manual is basically what we are looking at, and based on the standard for highway manual 2013 is 30 meters for right of way. I think that has been reviewed now, if I'm not mistaken, is around 47.5, I believe so, for your right of way. So you check for obstructions along your right of way. Like I mentioned earlier, if there are trees along that path, take note of the trees. Take point along those trees as well. So these are basically some of the basic things you need to look out for when you are doing your design. Let's just hover around these parts. You can see even along these existing areas, these areas that are around that part, if you look at them, if you hover your mouse, you can see that this is actually moving. It will tell you the elevation here. This is 581. So if you move, you can see 583, you can see 584. You can see this is basically telling you that this terrain is actually flat. Okay, so to pick your survey point, what I usually do, assuming we are designing for only this, we are not considering this, right? So if we are not considering this other one, we just want to design for just this one. What I can do is I can simply just delete this. I can click on add parts. So if I click on add parts, it's very, very easy to come up with. If I want to consider this roundabout, for example, if I want to design this roundabout, but maybe we should forget about this roundabout and maybe design the other one at the front, right? So we can do that as well. So I am just going to take this point. You can do it at a regular interval, like I said, but this is not very recommended to use for a real life project. You can use it for a proposal, just for proposal. By the time you are mobilized to do the job real life, you have to go physically and take this point. It's important that you go to the site with a surveyor and take this point. There's usually about 20 meters difference. So in order for you to avoid some little, and those those errors can be very costly in road, so it's advisable that you just visit the site physically and take your survey point, generate your survey data. The essence of this is just for you to be able to have a proper visualization of how your site looks like. Okay, another very key important information I need to say here is, when doing your real life survey, when taking your survey data, make sure that you ask the surveyor to take the point at the center. By the time he takes the point at the center, you should have an offset of 3 meters left and right, and then take another offset of 60 meters left and right, then take another offset again of 99 meters left and right, and all of that will give you about 18 meters span, right? That is very important in order for you to come up with a proper design. You should take note of the trees, just like I mentioned earlier on. You should take note of the inlet of your stream and then the outlet of your stream. Take points of about 50 meters. Those informations are very important to help you as the engineer who is coming up with your design on this road. So for our roundabout, I'm just going to take some random points here. So just take some points. We are supposed to have a road here. Okay, let me just have this goes this way. I'm not going to go too far. Let's just have this here. So I will take left, right, left, right, left, right. This is going to be very time taking. It's not going to be very easy to achieve, but it's worth the time. So let's say I have this, I'll do for here as well. You can see this road is an unpaved road, so but let's just assume that we are doing this design a bit. Let's just design maybe to this point, and then we can stop here. Let's take this point. Okay, because of time, this is going to be way too much. So when we get to maybe along this, when we cross this part a bit, we can stop, so that it won't be that much. The main thing is we have captured some of the major features I would have loved us to capture. So we'll capture that stream area where we'll propose a culvert there, and then we capture the roundabout, which is also very important. So okay, so we are almost across that particular stream, so this is good. It's good that we have gone across that stream. So we'll just go a bit further, and then I will stop there just for just so whatever we are having from here, I don't think it makes much, it doesn't make any much difference. So we can stop around here. So I will just stop here. So I will name this as YouTube. So I will stop here. Right, so I'll click on OK. Okay, so if you have been able to get to this point with me, I tell you a very big congratulations. You have done well. Okay, I spoke about reconnaissance survey. We're able to check our topography and be sure of our topography. So if that is correct, right now we are going to save this particular data as a place. So I will just right click on it and click on save place as. So I can save this as KMZ. So I'll save this data. So make sure you save it at a location or a directory that you can easily trace. So mine is on my desktop. You can see this is YouTube training. So there is a website that we will use in order for us to extract those data that we have been able to generate from our Google Earth. So you go to your browser and you search GPS visualizer. So you search GPS visualizer. I'm going to search visualizer slash elevation because some of them may not generate these elevations. The visualizer app software website rather stand to be corrected, but it comes literally like about two different, so you have like two different display of that website. So I want the one that will take me directly to where I can see my digital, this is assigned digital elevation model, elevation data to coordinates. So this is the one I am looking for. All right, so basically all I need to do now is just to click on choose file. So I will go to my desktop and I will search for YouTube training and I'll click on open. So it has opened that for me. So you can see here, convert and add elevation. The reason why I want this to convert and add elevation, some of them may generate your data for you to show you all that you need, but the elevation will not display. So it's important that you use this that will bring up your elevation. So all I need to do is just to click on convert and add elevation. So that is loading. Oh, I think okay, this is not what I want, sorry. I will export, I will save this as KML. Sorry, let me save it as KML, but I will rename it. I'll go back to my GPS visualizer and I will choose the file, new, convert. So this is basically where I'm facing that problem from. So I'm supposed to convert this to a plain text, right? Very important. I'm supposed to make this a plain text. So this is a plain text. So I have, so this is my, you can see my latitude, longitude, and then my altitude, which is my elevation. So I can simply just download this. So I will click on download. So it's a text. Right, that has been downloaded. I'll click on this, so it will take me to the directory where that file is. So I can just simply copy these files and take them to my Excel. And then I will look for my Excel. Good. So I'm here now. I will just delete this. Okay. So what I will do now is to make sure that I copy this. I have a converter that I usually use. So this converter helps me to convert latitude and longitude to easting and northing. So like so all I need to do is I can simply just go and copy my latitude and longitude, and automatically it will convert them to easting and northing. So I have highlighted them. I will just take it down to my converter, and I will simply just highlight this. So all I need to do right now is just to click on, there is already a data here, do you want to replace? So I will just replace it. So if you look at this very well, automatically the easting, northing, it has helped us to convert this to easting and northing, right? So all I need to do is just to drag down until the end of this, and then I will copy. So I keep going. Aha. So once you get to the ending of the data, you get to know. You can see there's a difference here. The easting, northing here starts from here starts from 12, 12, 12, 12, 12. This one is 10.5, like that. So you get to know once you get to the ending of that. So this is it. So I can simply copy this. What I normally like to do is to sometimes just use my notepad and then paste, because when I paste directly from into the Excel, sometimes it doesn't give me what I want. But let's try and see if we will get what we want. So let's say new blank. Good. You see, this is basically what I'm talking about. So I will use my notepad. But for the Microsoft Excel gurus, you can help us. But for me, this is just how I go around it. Control A to highlight, Control C to copy. So what I do is just to go through this way. If I go through this route, it will work normal. Oh, sorry. So when I copy this, let's see. Scroll down. So I'm not a Microsoft Excel guru. I barely use Microsoft Excel, so permit me if I'm not as fast as you expect me to be, as far as Microsoft Excel is concerned. Alright, so we are here. Now I have my, let's say this is one, this is two, okay. Okay. Okay, perfect. So as it is now, I have my point, I have my E, I have my N, I have my Z, right? But I don't have a description. Now, because I generated this from Google Earth, so I don't have a description for this. But one thing you should know is for a proper Excel, for a proper survey data, you are supposed to have a description. Unlike what I have here, which I generated, like I said, it is always recommended that you only use Google Earth to generate your data, just mainly for probably presentation. But for a real life project, I personally don't recommend it, because you have some difference of about even 20 meters and all of that. So that could be a whole lot for you when it comes to cost, right? So it's important that you after your presentation, after you want to do a real life project this time, it's important that you go to the site physically and take your data, right? But for the purpose of this class, we're able to generate our survey data from Google Earth, which is what we have right now. So we have our point, we have easting, we have northern, and then we have our Z, right? So then, since we now have all of this, but like I said, for a standard project, you are going to have a description. So if you look at this is sample of a survey data which was taken with survey instruments. So this is a standard real life project that was done. So you can see we have CLCL, which means center line. Sometimes it's important that you ask the surveyor what he means in his description, just in case you are not getting that clarity on it. Now FNC means fence, so based on what was done here. So we have the beginning of the fence, which is BEG, and then the ending of the fence. So maybe along where you are designing or doing your projects, you may have some fence, right? If you look at this Google Earth very well, you look at this very well, you discover there are some you see a lot of building structures by the left hand and also by the right hand side. If you look at this very well, this tells you that this is a fence, right? If you remember, we said when taking your point, if the surveyor is taking his point, it's important to know take out points for your fence. It's very, very important. But you know, this is already an existing road that has been done. So maybe for a new project where you don't have an existing paved road, there is high chances that you may have some fence that may fall around the right of way. You may have some trees that will fall around the right of way. So all of these informations are very, very important. You have a stream probably along the right of way, and then this road, if this road was never paved, then you have this road as already an existing road. You may need to take some points along this area in order for you, just like what we have here. We have this road which has not been constructed yet. So this is an unpaved road. Because this road has not been constructed, if you want to construct this road now, we need to know, we need to pick some points along this road, which is the edge of asphalt. Very, very important. So this edge of asphalt help us to, when we are constructing this road, so that it will fall exactly at the same level with this road, or else we are going to have problem. You understand? So if there's a difference in the levels, then there is a problem. So you must find a way to connect this road with this one. So these are all very key important informations that we must pick when doing our road designs. Okay, so if you look at this very well, these are all building structures along here. I'm sure this is a fence line, right? So this is also a fence line, and you know you cannot have a continuous fence from here all through. So you have a beginning of the fence that starts for this building, for example, and then you have the ending of this particular building, and then another fence can start from here and then probably ends here. So as simple as these informations that I'm mentioning here in this video can be, this is one of the most biggest challenges you are going to face when doing a real life project, right? So these informations are very, very important. You can see this is gate, GT gate. This gate is actually very, very important when you are doing your road design as well, because you already have some existing building structures. You don't want your road to be too far from the gate level in terms of height, when it comes to whether it is too high for it or it is too low for it. So there is a minimum height that your pavement should go, either above or below the gate level, right? So this gate that you see is one of the most important things that you must take note of, right? Gate is one of the most important points, I must say for a fact. It shouldn't be more than 6%, right? It shouldn't be more than 6% when it comes to the grade. It shouldn't be more than 6% along this gate area that you are seeing, right? And then you should not go more than 500 mm either below or above this gate level that you see. Any of these gates that you see shouldn't go below or above. These are very, very key, very, very, very key important informations. And then we have the ground, which is GRND. Like I said, for maybe some other surveyors, they may probably use a different description, you get. But one thing you should know, that these descriptions are very, very key, and they are very, very important. You can see the starting of a stream and then the ending of a stream, the starting of a stream and then the ending of a stream. So you have some streams here. This stream is very, very important. I mentioned it earlier on. At the beginning of your inlet, around the inlet of your stream, you should even pick some points about 50 meters. Around the outlet, also pick some points about 50 meters. They are very, very important informations that you should have in your survey data. Then we'll talk about the trees. Very, very important that you take your 3 points. You can see we have trees along this. So if you look at this Google Earth, I'm not sure we have any tree very close here, because like I said, this is an existing road. So for a new road, probably you may have some trees. And you know, I mentioned there is right of way. For highway, we have right of way, right? Which is it used to be 30 meters, but I learned that is 47.5 meters now. So you can go as far as measuring from this to know what distance you have. Is very, very important. But this is not like a major highway per se. So but these are the key informations that you should take note of when you are doing your road design. So you can just use this measure to check the distance. If you look at this, we have a fence here, and then we have another fence here. For those of you that knows this place very well, this is about 20.48 meters. So for those of you that know this area, I think custom office used to be around here. It's still around here if I am not mistaken. So you wouldn't want to do your road and then you are entering, or your alignment is going into the customer office. That means you are trying to demolish their offices, except in a case where you have done everything possible based on standard and nothing is going through. Then in that case, it may affect some fence, it may affect some building, but you will have to, as the engineer, find a way to run away from having all of this serious destruction, maybe bringing down fence, bringing down buildings and all of that. If you have done everything possible based on standard and it's not going through, but you must minimize it to the barest minimum. So that is what makes you a professional as an engineer. It's very important. You can see some very sweet curves that are here. We made a mistake. We would have just even designed this road instead, since it's not paved. This would have been a bit more interesting. Just maybe later we may probably go through this one as well, so that we can appreciate it. I think there is a graveyard around here, if I'm not mistaken. This is it. For those of you that knows this axis very well. So this is if you look at this, we have one very interesting curve here. We have one very interesting curve here. All right, so this would have been way more interesting to design than this, sincerely. Maybe if we had gone down to this point. So these are fence lines, these are fence, so the surveyor is supposed to take this point for us. You can see we have a tree here, but it's inside this building. So if we had this tree outside, probably we take that point. I think these trees are within this grave. We have a cemetery here, so but I think these trees are outside, so we'll take these points for these trees and all of that. So these are very key information, as simple as they may sound, but they are very key. They are very important, because if you cut down tree, you are supposed to pay normally per tree, because you are supposed to pay to a government agency, I've forgotten the name, which are supposed to replant them, so you pay for that. So that is why, as the engineer, in your design, you are trying to, in engineering we say safety and economical. That is basically what we always consider safety, and then we consider the cost. These are two very important things that we take note of as a civil engineer. So if that is correct, we'll come back to our survey data and let's look at what we have. So we have spoken about the three center line, edge of asphalt, like I explained earlier. You have some edge of asphalt, which is this. For example, if we are designing this road, we must find a way to connect it with the edge of asphalt here. Very important, so that you won't have this 1 meter above this particular existing road. If you have this 1 meter above the existing road, so what are you doing? You are definitely going to kill a lot of people. So you must find a way to connect this. So you must pick all those points if at all you are designing this particular road only, and then you must pick these points that goes like this in order for you to be able to connect this particular road with this one. So that is that. I have spoken extensively. We can also use this data as it is, even though we don't have a description. So you can insert those description if you feel like you want to have a description, but obviously we didn't take those points for those trees and those fence here, because this is not a real life. We are just using Google Earth to generate our points, so we didn't take all those points, so it's not going to be relevant here. So we can only just maybe name all of these center line. We can just name all these points center line if we want to do that. So but I wouldn't want to go into that stress right now. So if that is correct. So another thing I'm going to do now is to, and another very important information that I know most of the time people ask me of is, how do you tell which one of these is an easting and which of these is a northern when you are giving data? Because sometimes this can be interchanged. You can have the northern here and you have the eastern here. It's very, very possible, right? If that is correct, if you check these according to, based on my mentors, if you notice, you discover that the eastern values are usually less than the northern values. When it comes to the difference, you will see that the northern values are usually higher than the eastern values. So that is how I usually used to easily tell which is eastern and which of them is northern. That is just the basic or the major ways to know which of them is an eastern value and which of them is a northern value. So this is basically how to tell. So if you look at this now, like I said earlier, this is our point, this is our eastern, this is our northern, this is our elevation. Similarly, if this was to be here and this eastern value to be here, it will now be eastern, northern, sorry, it will now be point, northern, eastern, and then elevation, right? So by the time we open our Civil 3D software, I'll be able to explain that better in order for you to understand. I have spoken extensively on this. I wouldn't want to go too far anymore. A reminder, if you want to register with us for our Civil 3D course, which is coming on the 3rd of November. It's very, very important. All you need to do, all right, this file now as a CSV file is very, very important. The format you are saving your file is very, very important. So I will save it as a CSV file. I can go to my document and I will save this as YouTube training let's make it like this. So I will use comma separated value, which is the meaning of CSV, means comma separated value. So you can save it as a CSV file. You can also save it as a text file, but it is highly recommended you save it as comma separated value. Civil 3D recognizes any of this format. Any of this format is very, very good. Civil 3D will be able to recognize it. So once you do that, you can just save. So once I save my file, I can be able to open it in my Civil 3D. What I'm going to do right now is to click on my Civil 3D 2022. Now we have the metric and we have the imperial. So if your country are using the imperial unit like in feet and inches, you can use this. If in your country you adopt the metric unit, meters, kilometers, millimeters, you adopt this. So I will double click on my Civil 3D and allow it to load. All right, awesome. So we are in Civil 3D. This is our Civil 3D interface. This is basically how it's going to look like for you. It will interest you to know that Civil 3D is a two-in-one software. You can use it as AutoCAD. You can also use it as Civil 3D. All you need to do is just to switch the interface. Now if I click on this here at the top here, you see like an arrow pointing down. this drop down, if you come down, you see drafting and annotation. If I click on drafting and annotation, automatically the interface will switch to AutoCAD. So I wouldn't want to go into that. If you have Civil 3D, you can test that for yourself and see how it looks like. Similarly, I have another one by the side. If I click on this, I can click on show menu bar. Automatically it gives me most of my basic tools I'm going to be using for my civil tree, for my road design. So if you look at this, it literally is arranging everything for you according to the steps that you are supposed to go. Look at what we have on the first here. We have the point, we have surface. Definitely when you import your point, you create a surface, and then definitely before you talk about your alignment, before you talk about profile, before you talk about corridor, then you go to sections. If you want to introduce or have some pipes, you can also include your pipe networks. So it is arranged accordingly for you. We are going to be using that to achieve a whole lot. Now if you look at this here, we have what we call the prospector tab, we have the settings, we have the survey, and then we have the toolbox. What I always like to do is to come to my settings, which is very, very important that you do your settings. Mind you, we have established this is that establish the basic design speed we want to use earlier on. There are a whole lot that you need to put into consideration before adopting your design speed, but that is already going to be provided for you. Everything is based on Federal Ministry of Works, right? Now, but this helps us to see what our road falls. Our road is definitely an urban road, it's not a rural road, even though our road is a flat terrain, right? So our urban road, you can see for arterial street with extensive development, you use 40 to 60. So there is a specification, right? So if there is massive development around there, you use 40 to 60. So as at when they constructed this road, I don't know, I can't remember. I don't think if I even have an idea. I don't know if this area was massively developed as it is now, because as it is, everywhere is extensively developed. This particular, for those that are familiar with Kaduna, this is around the CBD of Kaduna. So we have our major business area is along this road, along this other major road. So this is very, very close to the main CBD of Kaduna. So this place is extensively developed. So it's either so we'll have to adopt the design speed based on what we have here, because this is a rural area, it is not urban, so it's the major Kaduna city. So we can adopt something around here, let's say 60 kilometers per hour, or yeah, we can say 60 kilometers per hour, or we can say 50 kilometers or 40 kilometers. This is basically what they are telling us. So either from 40 to 60, you pick a more comfortable speed for yourself. Now another thing that is also very, very important that you should take note of is for every design speed. So for every design speed, there is a minimum what we call K value, which I'm going to definitely be showing you that. And then we have the minimum gradient, so it varies for every design speed, right? So when you are dealing with let's say 60 kilometers per hour, the K value is different from when you are dealing with 80 kilometers per hour, or when you are dealing with 100 kilometers per hour. These are very, very key important informations that you should take note of. Right, so if you go to page 87 of our Federal Ministry of Works highway manual, if you go to page 87, that is on your computer if you have it as a soft copy, but on a hard copy it is definitely not going to be in page 87. Okay, but because for the soft copy it is at page 87, so please take note. So you have to carefully check through that on if you are having a hard copy of this. It's very important that you have this as a civil engineer that want to major on road. Very important that you have this so that you know what you are doing. So this tells us that for a flat terrain, and like you know, earlier we mentioned that our road falls within the category of a flat terrain, so the topography is a flat terrain. And if that is correct, and we said we are doing our design for flat terrain, we said we are adopting 60 km/h, for example. So if we are adopting a 60 km/h, our design speed now for our our grade, relation of maximum grade. So this is for our grade. Very important. You can see the grade for every design speed varies. So for 50 is different, for 60 is different. You can see as this design speed is increasing, our grade is reducing as well. So you can see for 50 is 60, for 50 is 6 rather, for 60 is 5, for 80 is 4, and then it keeps dropping. Similarly for rolling terrain, similarly for mountainous terrain. But we have already established that our road is a flat terrain, so we are adopting a 5 km/h 60 km/h, and then we say our maximum grade is 5. Now another very key important information that you must note is this: the minimum grade. For our minimum grade, I'm just going to go to the very most important information that we need. It said a minimum grade for the usual case is 0.5%, but a grade of 0.3 may be used where there is an adequate pavement, accurately crowned and supported on a firm subgrade. Right? So it is very important that we know about this. You can see, so we are using a 0.5 as our minimum now, but on a very critical case where you have done everything possible for it to fall within this and it didn't work, so you can also as well use 0.3, but this is the least you can go. Right? So this is basically what this is telling us. Very important information that you should take note of. So this is for our design speed. Another very important information that we need to know is for our K value, which is here. This is another very key information. So if you could remember, we said we are adopting 5 as our maximum, and then 0.5 is our minimum. So if we are doing our design, we must make sure that our grade falls within 0.5 to 5. I hope it is making sense. And then similarly, we must make sure that our K value, when it comes to our vertical curve, we are going to see how we demonstrate all of that. But it's important that we establish this knowledge in order for you to understand what we are doing. We are not just drawing lines and curves. Everything must fall within the standard. So mind you, if you are from any other part of the world and you are watching this, this design manual I'm using is from Nigeria. So this is our highway manual in Nigeria. So for countries it may vary. So in Kenya it may be different, in US it may be different, although we adopt the ASHTO, but we also have our Federal Ministry of Works highway manual that we use. Right? So if that is correct, we use the ASHTO as well, but we have our highway manual that we adopt. Right? So this is supposed to guide us on every standard that we should adopt. So if you look at this now, for our crest vertical curve for 60 km/h, we say it's 11. Now then for the sack vertical curve, we say it's 18. I hope it's making sense. So if you are designing at 100 km/h, it is 52 for your crest, it is 45 for your sack. but since it is 60 km/h, it is going to be 11 for our crest and 18 for our side. So I hope everything I have said is making a whole lot of sense. So if you come to the settings, you come to your drawings here, I will right click on it and I'll click on edit drawing settings. Very, very important. Now a window is going to pop up for me here. Based on the model we clicked on, it was for metric, so by default everything here is going to be based on metric unit, right? So you can see everything here is in metric unit. The category under our zone is very, very important. This is another very key important information, so you must do this for your design. So for some persons, they use Nigeria, and then they will pick Mina. Mina is already there, based on, it's based on the sea level, right? So based on sea level, and we have the two major rivers in Nigeria is River Niger and River Benue. So Mina is in Niger, is in Niger State. I hope that makes sense to you. So, but another datum that is recommended, you can also use the global, which is WGS84 datum. So you can as well take advantage of this as well. This is how you should go about it. So either for some persons, like I said, they use Nigeria, Mina. You can also use a global datum. This is also very okay. All right, so we are here. The next thing I'm going to do, like I said, we have prospector tab, we have the settings, and there are two ways, or two major ways, of also several ways, but we have what we call the survey data. I can import my data as a survey data. I can also import my data as a Kobo point. This is the most common and the most popular way you see people import their data. Just maybe I may show you how to import your data as a survey data. If you import your data as a survey data, is more like the automatic way of importing your survey data. It does a lot for you. I might demonstrate that even as we proceed with this training on Civil 3D, but I don't know for now if I will do that or not. But then let's say I want to use this particular method of importing my survey data, which is more like the manual method of importing your survey data. So if I right click on the point, that is, I'm in my prospector. Please, if you are on settings, you can't do that. Come to prospector first. You have to switch to prospector, and then you right click and you click on create points. So if I click on create points, I will click on this here which says I should import my point. Now, very key important information that you should take note of is that from our survey data we said we had in our survey data we had points, we have easting, we had northern, and then we had elevation. There is no description. So in essence, what that tells us is that we have P, we have E, we have N, and then we have Z, and it is comma delimited. We said comma delimited is what we are adopting here, right? So it's comma delimited, P, E, N, Z. I can show you that from our data itself. Good, this is it. So we have P, which is our point 1, 0.2 up to 0.64 points, however your points. Then we have the E, then we have the N, then we have the Z. We do not have description just like this one. This one has a description, which I stated it in the previous video, that it's important that your surveyor add a description. The description is very, very important. It's because we are just doing this as a training, so there may be no need for, we can omit that, or we can be excused by that. And I said obviously that you only use this whenever you are just doing a presentation kind of drawing, but for a real life project, by the time you want to do a real design, you have to visit the site and take up those points, and then make sure your surveyor add a description to those points. Very, very important. So if we are done with that, I can just click on this plus sign here. I think my point is here on my desktop. I'm supposed to close that so that it doesn't affect this import. Make sure that the file type is CSV, because I saved this as a CSV format, and I told you earlier on that you should make sure your file is either CSV or a text file, but just adopt CSV, it's okay for you. So whichever one you do, you still have or get the same result. So I will click on open, and then we wait for it. So you can see automatically our point has been imported. We have the point, we have the easting, we have the northern, and then we have the elevation. And then, so you must arrange this according to what you have on your data. So if I use this, for example, you know that it's wrong. So this is wrong. So I must make sure that it is according to how my data is arranged. That is what I'm going to pick here. So this is point, easting, northern, and then elevation. This here tells you that this is northern, easting, elevation. This is easting, northern, elevation. You understand? But we have points, so our own is point, easting, northern, elevation, which is correct. So assuming we have a description, we would have choose point, easting, northern, elevation, description. I hope it's making sense. So this is point, easting, northern, elevation, comma, delimited. Very, very important. Pick comma, delimited. So I'll click on OK. So I'll type ZE and I'll press enter. So if you're able to get to this point, I tell you a very big congratulations. Closely followed wherever possible to avoid adverse environmental impact on the inhabitants of the project road corridor. The following standards shall be employed in design. Now, this is very, very important. This is another very key important information that you need to know. For a two-lane carriageway width, we say is 7.3. So it means that each lane is 3.65. So each lane is 3.65. So each side of the lane, which is one directional lane, and then the each side shoulder width should be 2.75 for a highway. So this is another very key important information that you should take note of. For the road cross slope is 2.5%, very important. Shoulder cross slope is 5%. Then the maximum super elevation is 8%. Right? So these informations are very, very important that we should take note of. This percentage, very, very important. The cross slope shall be varied to suit curve super elevation requirement. I wouldn't want to go into that. And then but we have another key important information here, which is a minimum radius for our horizontal curve. I'm going to also speak extensively about that as we progress as well. But where I want us to take note of, we have stopping sight distance, we have passing sight distance. Is also another very key important information that you should know. There should be a minimum stopping sight distance required, then there is a minimum passing sight distance required as well. So on this sight distance, we have they also vary based on K value, right? So for 100 kilometer per hour road, now when you are designing for a 60 kilometer, it's different. The K, there's what we call the K value. It's actually also very different. So we are not using this information right now, so you can discard it, because this is for 100 kilometer per hour road. As we go into the Civil 3D proper, you are going to see where we are going to be using this, because we will have to import our design standards into the software. Very, very important. So here you can see sub-base lateral material CBR should be greater than 30%. The pavement design shall be hinge on a number of factors such as the strength of existing foundation of the pavement, properties of available soil cumulative standard, axial load for the design. I'm going to look for where all of this falls in our material, so I could show you directly here. I have it on a hard copy. The page, I can easily trace that. So on the soft copy, I will trace that quickly and also show you that. So there you can see, this is another very key important information that I would like you to take note of. And then there are so many other informations I'm going to be releasing even as we progress, in order for you to have a clearer insight of how to come about your design with Civil 3D. So the sub-base lateral material CBR should be greater than 30%. This is a very, very key important information. You can see our subgrade means, let me show you a typical cross section of a flexible pavement. Flexible pavement is the one that has the asphaltic, which is basically the asphaltic kind of pavement. Then the rigid pavement is like the concrete kind of pavement. Now this is the cross section of this flexible pavement. You can see we have the surface course, base course, sub-base course. Now this is, if you look at the cross section, the subgrade means the existing soil, what you have, what you meet on the sites there, the existing soil, and that soil need to be tested. Now by the time that test is being done, now it should fall within this at least, or else it should fall above 10%, so, or greater than or equals to 10. So if it is 5 to 9 is fair, if it is 3 to 5 is very, very poor. So it's 4. That means we have fine silt sand, clay silt, organic soil, all this kind of soil, they are not good when you meet them on your site. So they are not good. That means you have to cut this soil entirely, replace them. So we have the clay, gravel, clay, sand. This is a bit fair. So but when you have a gravel, crushed stone, sandy, now based on our standard, this is what is recommended for us in our highway manual, which I am showing you here. We have the sub-base lateral material CBR should be greater than this. So we have our base, under our base, based on this cross section that we have here. You know, we said we have a cross section of our pavement. So this is the base here, at this, which is the one following the surface course. After your surface, we have the base course. So that base course, now this is what we should have. It should be stone based material, and the CBR should be greater than 80% soaked. So our surface should be 100 mm asphaltic concrete. I'm going to also speak extensively on that even as we progress. But let's come to this pavement material I was showing you just now. Very, very important. All these informations are very key in order for you to achieve a very good design. You know, we have definitely, when you are doing a design, vehicular load when it comes to pavement is also very, very important to take note of all of that. So you can see we have different cars. We have for a car, we have for a delivery truck, for a loaded 18-wheeler. You can see the loads are different. So you can see that this load here is 0.0007. This one is 0.1. You can see the gap between this and this is far. So you can see the gap between this and this is also very far. The gap between. So if you do your design with this kind of load, and then this is the load that is climbing that road, you can imagine what will happen. And every road has a lifespan. I was showing that it says the pavement design shall be hinged on a number of factors such as the strength of the existing foundation of the pavement, properties of the available soil cumulative standard, axle load for the design period, very very important, of 20 years. So a road should have a lifespan, right? These are very very key important informations. Please, as you are watching this, make sure you are taking note of all of the standards that I have mentioned from the beginning till now. I think I will still have to end this video here. I've been able to talk extensively on all of these informations. Mind you, we have our training coming up on the 3rd of November. It's very very important that you take note of. Register, invest in knowledge. Is one of the wisest investments you can ever do in your life. Is investing in yourself. Is one of the best investment anyone can do, because there is a whole lot of information that I am not going to talk about on a free kind of course. So it's important that you register so you can be grounded in road design. Episode we are going to do a design criteria check, very very important, which is one of the most important thing that you should do as well on your design. So I will just type design criteria people. This is what we'll have. So automatically it will take me to that window. If you look at this, if I click on this drop down menu, you can see this is metric, so everything linear unit is in meter. You can change that if you want it to be in kilometers. However, the area is in square meters, the volume is in cubic meters. You can play around with that and change any of that. Automatically it will take effect on your design. So you can see we are using Staad.pro, obviously, like you know, so we can update whatever is here on our Staad.pro, because everything we are making reference to as far as Nigeria is concerned, we adopt the Staad.pro. So only that there are some little improvement that we have done, but everything is basically because all of this research was done by Staad.pro. So this is Staad.pro 2011 metric. This is for your super elevations for 4%. You can see what we have for. You can check this minimum radius table from your what do I call it. This is for super elevation for on your highway manual. So you are going to see all of this information. So this is my highway manual. You can just see what I have here. It's starting from 50 kilometers, 60 kilometer. So for your 50 kilometer, you can double check that based on what you have from your civil 3D manual. So you can see what we have. So you can as well confirm all the information that is here. We are using 60, so this is for 4%, and we said is 135. So you can double check all of those informations from what do I call it, from your highway manual. You can see we have for a super elevation of 4% here, we said is 135. So you can see it's actually very very correct with what we have. It tallies. So you can take our time to check all of this and play around with it. So if here I'm not, definitely I don't have 15, I don't have 20, I don't have 30, I don't have 40. I can basically just remove as many that I don't want from this my table. Similarly, I can do for 6% for this and this and this and this and this. So by the time you are good with this, you can rename them to Federal Ministry of Works Highway Manual instead of what we have here, which is Staad.pro 2020, right? So you can change that information and save it somewhere so that you can always use it whenever you want to work. Similarly, for your crowned round way, you can play along with this. So you can check for your super elevation. You can see super elevation attainment method. You can play around with this, but it's not something far from what we have from our highway manual. So you can check all of these based on from our alignment, right? So let's say we come back to our profile. You can see this is minimum K value tape rules for our stopping sight distance. I said I was going to briefly talk about this. You have to check, our design speed is 60, so we can check our stopping sight distance or just check basically our sight distance. Let's look at that in our highway manual. So if you come to here, I will just type sight distance. So let's see, passing sight. Good. So I'm here. So let's look at that table. You can see sight distance standard. So for 60, remember we said from that material 400 was different. You can see every design speed has its own sight distance and has its own passing sight distance and also stopping sight distance, right? You can take out time and do a little research on sight distance, on stopping sight distance, on passing sight distance. So you can see the value varies based on your design speed as well. So your design speed, basically your stopping sight distance, is when you are climbing a particular hill, like your vertical curve at the crest. Now at a particular speed, and our speed is at 60 km/h. Now at that point, if there is another car which is approaching from the other side, or maybe a cow or maybe sheep that are crossing, going across that particular road, by the time you apply your brake and there is a particular distance you are supposed to have been able to stop, which is called the stopping sight distance, in order for you not to hit that particular car which is approaching or whatever that is crossing that particular road. So it's basically what we are talking about. Passing distance is just basically passing a particular approaching vehicle at what distance and all of that. So and all of these are provided in our highway manual, and you can take our time to read all of this. You can see passing sight distance, the minimum sight distance that must be available to enable the driver of one vehicle to pass another vehicle safely and comfortably without interfering with the speed of an oncoming vehicle traveling at the design speed. Should the oncoming vehicle come into view after the overtaking maneuver is started, the sight distance available for passing at any place is the longest distance at which a driver whose eyes are 1.05 meters above the pavement, so your eyes are 1.05 meters above the pavement surface, can see the top of an object which is 1.3 meters high on the road. So this is very, very important. At least you can see based on what we have here. These informations are very key informations. So we are also going to be considering all of that even as we continue with our design. You can see the stopping sight distance, another very key important information. Stopping sight distance is minimum sight distance required on the road to enable a vehicle traveling at design speed on a wet pavement to stop before reaching wet pavement. This is very, very important. When it rains, you all agree with me that when you apply a brake, it's different from when the surface is dry, right? And when you apply a brake, it doesn't really work very, very effectively compared to when you have a wet ground. So this is a very key important information. The distance traversed by the vehicle from the instance the driver sights an object necessitating a stop to the instant the brakes are applied. The distance required to stop the vehicle from the instant brakes are applied. These are, you can see the stopping sight distance is measured from the driver's eye, which are assumed to be 1.05 meters above the pavement surface, to all objects 600 mm high on the road. So these are very key important information. I know I have been talking extensively. We've been just doing theory. We've not really drawn any line, any horizontal alignment or vertical alignment. I know a lot of persons are eager to see us do all of that, which we are going to do, but we need to establish all of these before we can then go into all of that. So all of these informations are very much available in our highway design manual. It's very important that you cross-check and be sure that it aligns with our highway manual, or else you will have to come to that table and edit them, right? It's very, very important that you do all of that edit before you proceed with your design. So that is that. I'm still going to talk about something very key here on Civil 3D. So it is always advisable that when you are done with every of the check and you are sure that everything is okay, you may have to probably rename all of this. Just give it a name, maybe Federal Ministry of Works and Highway. By the time you are done with all of your editing, everything you have double checked, everything tallies, or if there be any changes, you effect that change on those tables that are here, so it can suit whatever we have. You know, our highway manual, some of those data are being updated. So if you check, this highway manual I'm using is 2013, so probably there have been some changes. You will have to effect those changes on these tables and then you save them. So we have already one that is pre-saved, that has been saved already as a template that I'm also always going to be using. So if you, let's say you want to save your own highway manual design standard, so all you just need to do is just to click on save as. You just save as and then you give it a name and then save it to whatever directory you want to do that. So I wouldn't save this, I will just close this because I don't want it to affect whatever is there already before. All right, still on design checks, if you could remember, we spoke about grades previously. This grade, how do you include this in your Civil 3D for your check? It's also very, very important. So we'll have to include this in our design check, and that is not part of that design criteria that you see there. So we'll have to add this information as a design check. So it checks our design as we draw our horizontal alignment and all of that. It will check all of this slope. It will alert us the moment we violate any of those. Once the slope is too much, once we go below 0.5, it will alert us. Once we go above, we said our flat terrain 6, once we go above 5, it will alert us. So this 0.5 is telling you that at least for the water to be able to drain out effectively. So, and in a worst case is 0.3. So 0.3 is the worst you can go. By the time you go less than 0.3, that means it can't drain out the water. So that slope is too small for the water to flow out effectively. So and then 0. And then 5 is the highest you can go. If you go more than 5, it will be too steep for 60 km per hour speed. So this is basically what all of that is telling us. So how do we add this information now into our Civil 3D? So we have 0.5 here, and then we have 6, and then we have 5. So this is what we are going to be adopting in our design check, and we are going to add that into our Civil 3D right away. So what I will do quickly is just to come to my settings here, and I will click on my profile. If I click on profile, you can see what I have here. I have what we call design check. So if I click on this plus, you can see we have for line, and then we have for curve. So we can do a check for our line, can do a check for our curve. So if you look at this very well, you can see we have this design check. Let me show you something quickly. let's say for example we want to create an alignment. We are not creating alignment yet, but I just want to show you something quickly. You can see based on what we have here, if I click here design criteria and I click on check this, if I check this now, this is based on 100 kilometer per hour, and I'm not designing this road based on 100 kilometer per hour. We have used design check set. This design check, you can see what we have here is basic. So we want to create our own design check set, and you know what we are designing is based on 100 kilometer per hour. So definitely every information that is here is not basically what we are going to use, right? So we have our own maybe like a design standard that probably we want to adopt. You can see we have some design standards here, but I'm just going to leave everything as it is here. I will be showing you even as we progress. We'll be using our own pre-designed standard that we have created already. So we'll just select that and it will reflect here. Every properties of that particular standard will reflect here. And then this use design check set is very important, so we are actually going to create ours. So I will just cancel this quickly. So all I need to do now is to click on this design check set, and I'll right click and I'll click on new. So if you look at this here, all I need to do is to give it a name on my information. So quickly what I will do here is to name this as let's say this is, so I will name this Ministry of Works Highway Manual, let's say 2018, right? So I can just simply click on this and I click on OK. So if you look at this here now, I have this, right? So if you look at this, I still have that basic. I have Federal Ministry of Works Highway. So I will just click on my line here and click on new. So all I need to do here now is to name this, I'll say minimum gradient, which is greater than or equal to 0.5, and I'll close the bracket. So I can say this is for 50 kilometer per hour road. So the first thing I will do is just to add my absolute, because it could be positive, it could be negative, and then I will come to here. I will click on tangent grade, because that is basically what I am designing for, I'm checking for that. And then I will use my greater than or equals to, so it should not be less than 0.5, right, percent, if you can remember. So this 0.5, when you divide it by 100, you have a value of 0.0 0.005 rather. So this is what I'm going to be having as that. So I can simply just click on OK. So similarly, I can just add another new one. This time around, I'll call it maximum gradient open brackets. So this is going to be less than or equal to. Now you remember that our maximum is 5. If you can remember from what we have in our highway manual, they said it should be 5 for a 60 kilometer per hour. It should be 5. So our maximum is 5, if you can remember. So maximum is 5, right? So I say for a 60 kilometer. I think I made a mistake in the other previous one. Per hour, 60 kilometer per hour. So what I'll do here, I will edit that right now, and I will add my tangent grid, and I'll close my brackets, and then this is going to be less than or equal to, so it will not be 0.05. You remember this one is 5, so I will click on OK. So this is for 60 kilometer per hour road. So I can come back here. Number is 5, so just to double check that. For my minimum, let's see. I think I did one small mistake. Okay, I think there's no mistake here. It's okay. It is this manual, this that I need to edit. I think I gave it something different. Okay, I think everything is okay. Okay, this one is the description, I think, for a. Okay, we can just leave it at that. We already know what we are doing, and we know whatever we are doing is correct. So our design check sets, let's just come back to our edit, and let's see. We said this is for a 60 kilometer per hour right? So let's populate this. For our line here, we have a minimum of this. I'm going to add it, and then for my maximum, I'm going to add this, and I'll click on apply, and I'll click on OK. So we have been able to achieve that for our tangent. Now another thing you need to know that is we are also going to, as we proceed, talk about that of our curve, which is very, very important. There is what we call the length of the curve, and there's what we call the minimum. There's what we call there is a minimum radius of curve that we must take note of, and then there is a minimum length of that curve that we should also take note of. Over time, we've experienced how that your curve may pass that radius of the curve. You may use the actual radius of the curve, which is the minimum radius of the curve, but it will not pass that length of curve. We'll talk extensively even as we progress on that. So most especially that is usually on even in our alignment, and we are going to look at that. You can see for curve, for line, even as we progress, I will explain extensively on all of that. My name is still Abel Gray Cantoma. I'm from GREYTEST Design Consult. This is my WhatsApp contact. You can reach me on this number or call me on any of these numbers. Our training is starting on the 3rd of November 2025. There is a whole lot I'm going to be talking extensively on that training that you will not find here. Today I would like us to look at another survey data. I'm having some little challenges with the previous one, so we might most likely still come back to it, or we'll just probably pick up another more complicated data to work with. I wouldn't want to waste too much of my time doing all of that. But if you are able to go through that process and everything works smoothly for you, I tell you a very big congratulations. This is basically how to go around it. Now, to go further on this training, this is another survey data that has a description on it. It's very important that we even use a data that has a description in order for you to have a deeper insight, because in most cases you are going to be working with data that has a description. So you see, this has a point, this has easting, nodding, elevation, and then description, right? So we'll quickly import this data into our Civil 3D. So I will just come to my point, I will click on create point, I will click here, import this point, I'll click on this plus sign. It's on my desktop, road sample design. I hope it's not still open. It's open, so I'll close it here. I'll click on open. So this is it. I will select point, easting, nodding, Z, description. This is how it is being arranged from our survey data, and I'll click on OK. So I will type ZE and I'll press enter. So you can see that this point has been imported into our Civil 3D. So in a case where you are given a survey data, by the time you are done importing it, those descriptions, just like we did earlier on in the previous video, is important that you understand what is on that description. And like I said, it's also very important that know the location of the site where this road is going to be. It's important that you ask these questions. Ask where the location of the site. That's if you have never visited the site before. And another thing that you can also do, that is important that you do, is import the point or locate the point in your Google Earth, which is also very, very important. So if you look at this from our Civil 3D, I will just come to any of these points. I will right click on it. I will click on properties. So if I click on the property of this point, automatically here down under this geometry, it will show me the easting. So I can simply just copy my easting and I'll come to my Google Earth. I'll click on this pin here which says new place mark. So I can place a mark. I will just name it A. So on the east, I will just paste this and then I'll highlight this, I'll delete it. Similarly, I will copy my nodding, Ctrl C, and I will come to my Google Earth as well, and I will paste it. So I will click on OK. So by right, it's supposed to take me to the exact point where that road is, where it's starting from. So similarly, I will come back to my Civil 3D and I'll come to another point here. Let's see this point. Let's say I click on this one, this particular point. I will come to the properties of this point. I hope I'm selecting the right point. It's very, very important that you are selecting the right point. So I will just scroll down to where I have my, oh, this varies. I don't want it varied. Let me just pick another point. Alright, good. So I'll copy this. I'll come back to my Google Earth and I'll pick this new place mark and I'll name it B. You can name it whatever you want. You are at liberty to do that. So I will also copy the nodding. And I'll go to my Google Earth So if you look at this very well, I rotate this a bit, you see this is where this road is starting. We have an existing road here, which is an existing pavement, and then this is where it stops. So it's connecting two different roads. So we have a road here, existing road. We have another existing road here. So if you go back to your survey data, you can see that we've not really actually started the design per se. So all that we have been doing, you can see we have this. So like I said earlier on, every surveyor has a way of representing his description. So you can see we have PT here. So like I said, surveyors represent their descriptions differently. So you may have to ask at some point what some particular description means. So BLD, I believe this is building. So it tells you around this point we have buildings, we have a center line. So whichever one you don't understand, if possible, you can put a call and make inquiry about it. Ask the surveyor about whatever particular point that, or whatever particular description that you do not understand. What I usually also like to advise is that you always visit the site physically to see what is going on. But for the purpose of maybe for a proposal, you can also trace from your Google Earth to that particular location in order for you to have a view of what is going on. Although it's not going to be as precise as when you visit the site physically to see for yourself. Because when it comes to your Google Earth, it is updated after every six months, and 6 months, you agree with me, is a long time. There could be some changes along that route, maybe a new structure, maybe something that might affect your design might probably be on that location within this next 6 months. So if that is correct, it's also that is why it's very important that you visit, have a physical inspection, do your reconnaissance survey. Very important. If you look at this very well, I think we have like a fence around here. So I have spoken extensively from the beginning about all of these things, so I may not talk very much about all of these in this particular video, but I know that for as many that have been following from the beginning, I'm sure you already have some clarity by now. So if you look at this place, we say it's a building. You can see we have some buildings here. So we have buildings here, so which was represented as BLD. So I can probably maybe rename them as fence or however I want it, right? Or just leave the name building. So I believe along this fence line was where these points were taken, which are very important. So you look out for all of that. Part of what you should look out for, existing trees that are along that path, maybe existing drainages that are along that path. So I don't think I have any of such. So you can use your Google Earth to do all of that. So you can see Google Earth is a very powerful application or the software that you should take advantage. So you can see how the terrain looks like. All right, so it's making sense, I believe. So if you ask me, I will tell you that we have been able to do a whole lot when it comes to design. Remember, you should always check for the topography and all of that, which I have spoken extensively about all of these things. So I wouldn't go deep into explaining all of that again like before. So whatever I'm going to do here, I'm going to assume it's a flat terrain, and we are going to be designing it at 60 kilometers per hour. So everything we have adopted from the beginning, I'm going to continue with all of those data like that. All right, so let's go back to our civil 3D software. So I will simply look at my entire descriptions and the elevation as well. This elevation description. Okay, so you can see it's looking very large, so I can reduce that 1:200. So our descriptions are going to look a bit smaller now, so we are good to go. If you have been able to watch to this extent, I'll tell you a very big congratulations. I'd like you to just reproduce all that I have done right from the beginning. I have created very powerful, interesting, very educative courses on road, on structures, on mechanical, electrical, and also on architecture using different softwares. If you like what you are seeing, make sure you just give this video a like, drop a comment, subscribe to this channel. Is actually 100% free. Make sure you click on the bell icon so as for you to get a notification whenever I post videos like this. I post very powerful videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. Make sure you stay safe and stay blessed.